Hello everyone, welcome to video lecture series of Communication Engineering. Today's topic is types of noise in communication. In this video, I'll be talking about the noise, what do you mean by noise, and the classification of noise. So let us begin. What is noise? How can you define this particular term? So noise, you can define that it is an unwanted signal which interfere with the original signal. So when noise interfere with the original message signal, then it is going to corrupt the message signal parameters, and noise can enter at the channel, whatever the medium of the communication, means it can enter at the channel itself or at the receiver. So these are the two possibilities where the noise can enter and corrupt the original signal. You can see in this particular diagram, some variation is being shown. On the x-axis time is being taken, on the y-axis amplitude, and now here you can observe the impact of noise on the signal, how signal is fluctuating. Means at any instant of time it's difficult to predict, means there is no specific pattern, no certain pattern you can observe. It means noise is a kind of signal which has no pattern. It has no constant frequency or amplitude. So noise is a random and it is actually unpredictable, right? So random nature is of noise, and measures are usually taken because our requirement is to reduce the noise as much as possible in the communication system to improve the system performance. But noise cannot be completely eliminated. It can be reduced as much as possible, but it's difficult or impossible almost to eliminate it completely. So there are some of the examples of noise, like noise you can observe in the case of the radio receivers. So in receivers, several electrical disturbances produce noise, and therefore modifying the required signal is in an unwanted form. So in the case of the radio receivers, noise may produce his type of pattern in the output, means at the output which you are listening at the loudspeaker. So his type of pattern. Similarly, if you talk about TV receivers, noise may produce snow, and snow it becomes superimposed on the picture output. So snow or flicker is the case of the television receivers. Similarly, you can observe a buzz kind of sound in the case of the telephonic conversation. So you can say that noise is a factor which is going to impact a lot the signal quality, and noise may limit the performance of a communication system. So what are the various effects of noise? Noise can limit the operating range of the system, noise affect the sensitivity of the receivers, noise limit the performance of overall communication system. So there are various factors. You can see how much spurious this is. Now let's discuss the classification of noise. There are various ways of classifying the noise, but conveniently noise may be classified into two broad groups, and these groups are external noise and internal noise. So noise has been classified into two major groups. One group is external noise and other is the internal noise. External noise, the first type, the first group. So external noise, it can be defined as that type of noise which is generated externally to the communication system. Externally means whose sources are external to the communication systems, and external noise cannot be analyzed quantitatively. There are various types of noise which may fall into this category. Those are atmospheric noise, extraterrestrial noise, industrial noise. All of these kinds of noise I'll be talking in much detail. So noise is what? Noise is any random interference to a weak signal. The second type of noise categorization, which is the internal noise. So internal noise is a type of noise which is generated internally. From the name itself it is clear. It is generated internally or within the communication system or receiver. Like an internal noise, it may be treated quantitatively. There are various types of internal noise. The various types are short noise, partition noise, low frequency noise or flicker noise, high frequency or transit time noise, and thermal noise. So these are the various types of noise which fall into the category of external noise or internal noise. So let's talk about each of them in detail. First is the external noise. So here I will be talking about the external noise. You must remember that external noise, it is defined as a type of noise which is produced by external sources. Means it may occur in the medium or the channel of the communication. This type of noise cannot be completely eliminated, and external noise are analyzed qualitatively. Means quantitatively analysis is not possible. So these are the various factors. And in addition to this, you must remember that for a geographically point or a location, external noise cannot be controlled. Means this particular type of noise control, it's not possible. But reduction in the noise can only be done. It means to reduce the effect of external noise, the only way is to shift the communication system to the other place, because these are the contributed by the external factors. So if the communication system is to be shifted to the other place or other location which has comparatively smaller external noise factors, then this particular kind of noise can be reduced or minimized. And because of this particular reason, the satellite earth stations are generally located in the noise-free valleys. There is always a possibility to shift the earth stations from one place to the another place, right? So those earth stations are located in the noise-free valleys. As I have told you that there are three types of external noise. First is the atmospheric noise. Atmospheric noise, it is also known as a static noise. This is a very important point, and it is produced by lightning discharge in thunderstorms or other natural electrical disturbances which occur in the atmosphere. So these various atmospheric effects, they creates a noise and which is going to impact the signal quality. It means when we are talking about the thunderstorm or other electrical disturbances in the atmosphere, so these electric pulses, they are random in nature. It means this energy is spread over the complete frequency spectrum which is used for the radio communication. So atmospheric noise, it contains spurious radio signals which are distributed over a wide frequency range. Right, and the field strength of atmospheric noise, that varies approximately inversely with the frequency. Means there is an inverse variation with the frequency. It means large atmospheric noise is produced in low and medium frequency bands, whereas small noise is produced in VHF and UHF. So for VHF band and UHF band, these are used for the small noise. Means if the application is to be done in these bands, the impact of noise will be less. Atmospheric noise becomes less severe at frequencies above 30 megahertz. Second type of noise is the industrial noise. Industrial noise, it is also known as a man-made noise. Man-made noise. So this is the type of noise which is produced by various sources like automobiles, aircraft ignition, electrical motors, switch gears, leakage from high voltage transmission lines, and various other heavy electrical equipments. So such type of noise is produced by actually arc discharge that takes place during the operation of all types of machines or equipments. And industrial noise or man-made noise, this is quite intensive in the industrial area or dense populated urban areas. See, industrial noise in such areas are very strong in comparison to other sources of noise in the frequency range, which extends from 1 megahertz to 600 megahertz. So industrial or man-made noise, that is highly variable and hence can be analyzed statistically. So this type of noise can be analyzed statistically. Third is the extraterrestrial noise. So there are various types of extraterrestrial noise or space noise depending upon their sources. So the various types are divided into two categories. One is the solar noise and other is the cosmic noise. See, what is solar noise? Solar noise is the electrical noise which is emanating from the sun. Under the steady state conditions, what happened? There is a regular radiation of noise from the sun. See, this radiation of noise from sun, why? This is because sun is a big body at an extremely high temperature and it radiates electrical energy in the form of noise over a wide frequency spectrum, which includes like various applications may occur over there. So it means because sun is having a very high temperature and it also radiates, so that is going to contribute certain amount of noise and that is known as a solar noise. The second type of noise which we are talking about, the extraterrestrial, that is the cosmic noise. See, you are aware that there are various distant stars in the space and those distant stars can also be considered as a sun because these distant stars have high temperatures and they radiate noise in the same manner as the sun does. But the noise received from these distant stars in thermal noise and that is distributed almost uniformly over the entire sky, means there is a uniform distribution in the entire sky. So this type of galactic noise, that is quite intense, but since it comes from very distinct source, so the angle subtended by the earth, that is very small. It means the strength of galactic noise which is received on the earth, it gets almost diminished. Right? So this is how you can explain the various types of noise which comes into the category of external noise. Now we are talking about the internal noise. So internal noise is a type of noise which is produced by a receiver component while functioning because of the components in the circuit or due to the continuous functioning. Some of the components may produce certain noise. This type of noise is quantifiable and a proper receiver design may lower the effect of this internal noise. If the receiver designing is to be done in a very accurate manner, this particular type of noise can be reduced. There are various types of internal noise. Let us discuss them. First is the short noise. So short noise, it arises in the active devices. This is an important factor. It arises in the active devices, and why? Because of the random behavior of the charge carriers. So because of random behavior of charge carriers, short noise exists. Like in the case of the electron tubes, short noise is generated due to the random emission of electrons from cathode, while in semiconductor devices, short noise is generated due to random diffusion of minority carriers, or you can say simply because of the random generation and recombination of electron hole pair. So this is how short noise may occur in the receiver design or in any of the other component, and it impacts the signal quality. Second is partition noise. Partition noise, this is generated in a circuit It is generated in a circuit itself whenever a current has to be divided between two or more paths. So when a current is being divided in between two or more paths, this type of noise occurs. It means partition noise results from the random fluctuations in the division, or it is expected that in such type of cases diode must be less noisy than the transistor. See what happened, the partition noise, it has a spectrum like a flat spectrum, and there are three terminal components in which control terminal draws less current and are less noisy. You have studied the various three terminal components like transistors, FETs, etc. So what happened in a recent time, metal oxide semiconductor field effect transistors, which is MOSFET, they have been developed which draws almost zero gate bias current. And because of this reason, these devices have low partition noise and they find applications in low noise microwave amplification. So now you can understand how partition noise can be reduced. Next type of noise is the flicker noise. So flicker noise or low frequency noise, it is also known as a low frequency noise. So at low frequency means below few kilohertz, a particular type of noise appear which is known as a flicker noise, and the power spectral density of this particular noise increases with decrease in the frequency. So this particular noise, flicker noise, or sometimes it may be written as 1 upon F noise. What happened in the case of the vacuum tubes? The main cause of the flicker noise is what? Slow changes which takes place in the oxide structure of oxide coated cathodes and migration of impurity ions, right? So mathematically you can write the power density spectrum of flicker noise that is inversely proportional to the frequency, means S of W, this is inversely proportional to 1 upon F. Next type of noise is the transit time noise. It is also known as a high frequency noise. So it is generally observed in a semiconductor devices when the transit time of charge carriers crossing a junction that is compared with the time period of the signal, right? So some charge carriers diffuse back to the source or emitters, and this particular process gives rise to the input admittance in which conductance component increases with frequency, right? And when conductance component increases with frequency, so it has a noise current source which is associated with it parallel. So what happens, the conductance which increases with frequency, the power spectral density will also increase, and the type of noise can be observed as a transit type of noise. Last type of internal noise, that is the thermal noise. So the thermal noise or white noise or Johnson noise, these are the similar terms. It is a random noise which is generated in a resistor or in a resistive components of a complex impedance because of rapid and random motion of the molecules, atoms or electrons. So this type of noise is called as a thermal noise. So I hope now you will be able to define each and every type of noise in detail. Thank you so much for watching this video.